Okay, so we're on Chapter 10, Video Assignment 1, Part A. What mass of iron in grams is formed in the reaction? So, basically what we have to do, it's given that there are 2.66 grams of, we aren't sure what the formula is yet, so this oxide. So we're going to subtract that from the moles of oxygen, or the grams of oxygen that we find out to be able to find the grams of iron oxide. So, with the ideal gas law that we know, PV equals nRT, we're able to find, from what's given to us, 0.988 atm times the volume, 1.136 liters, equals N. That's where we're trying to find the moles. And then, so that's where we're trying to find the moles. And then the R constant is 0.08206 times the temperature, 298 K. So that's what we're given. And then we just solve for N, which is 0.0459.046 moles of oxygen, converted 16 grams per 1 mole of oxygen. It's going to be 0.736 grams. So 2.66 minus the 0.736 equals 1.924 grams of iron formed in the reaction. So that's the answer for Part A. And then Part B, we're going to be looking at what is the formula of this oxide. So we're going to take the 1.924 grams of Fe. There we go. 1.924 grams of Fe that we just found in Part A, and transfer that to moles, which is 0.0344 moles of iron. And we already found out the 0.046 moles of oxygen from this previous part of the problem. And so we're going to take those ratios, divide by the lowest one, which is 0.0344. So that's going to give F of a value, Fe1, oxygen, 0.046 divided by 0.0344, 1.35. You times those by 3 to be able to get this formula of Fe3O4. So that's the answer to Part B, the formula of the oxide. Okay, so then we get to Part C. So it's given that the cell length has an edge length of 8:39 p.m. So we can use that to find the volume. Given the density was already given to us at the very beginning, which is 5.2 grams per centimeter per cubic centimeter. And so 839 into centimeters would be 8.39 times 10 to the negative 8. And then from there, you cube that. I'll just show you the calculator. 839 times 10 to the negative 10. So that's in centimeters. And then you would cube that. So it would be 5.9 times 10 to the negative 22. Right there. That's the value that we found there. That's the volume in centimeters cubed. So then, to find the moles, or the mass, I should say, you multiply 5.2 times this value, and then multiplying those two together, you get an M value of 3.07 times 10 to the negative 21. So we're going to take that value and transfer it to atoms of oxygen and atoms of iron separately. So starting with the atoms of oxygen, 3.07 times 10 to the negative 21 grams. So that's the molar mass of Fe3O4 to 1 mole. And then 1 mole of Fe3O4 to 4 moles of oxygen. 1 mole of oxygen, Avogadro's number. Calculate all of that. That's going to be 32 atoms of oxygen. Same thing with iron. You're going to take that M value that you found before, and then transfer it to moles, 231.55 grams of Fe3O4, which we already knew right there, to 1 mole. And then 1 mole of Fe3O4 is equal to 3 moles of Fe. And then Avogadro's number And then you got 24 atoms of Fe. So that is the answer to C. 32 atoms of oxygen and 24 atoms of Fe.